Now, let's discuss about the measures of relative position. Measures of relative positions are conversions of values, usually standardized test scores, to show where a given value stands in a relation to other values of the same grouping. Z-score or standard score. A Z-score measures the distance between an observation, in the mean measured in units of standard deviation. Using the formula, value minus mean over standard deviation, population data, we're using this formula, x minus mean over standard deviation using this symbol, and for sample data, we're using this x minus mean over standard deviation. Take note that if the z-score is positive, the positive score is above the mean. If the z-score is 0, the score is the same as the mean. Now, if the z-score is negative, the score is below the mean. Okay, let's try an IQ test. A mean of 105 and a standard deviation of 20. Find the corresponding z-scores for each IQ. So, using the formula, x minus mean over standard deviation, we have 88 minus 105 as the value of mean over 20 as the standard deviation. And the answer is negative 0.85. Since the answer is negative, therefore 88 is below the mean. So using the same formula, we have x minus mean over standard deviation. We have 122 minus 105 over 20. And the answer is 0.85. Since the answer is positive, therefore 122 is above the mean. Using the same formula, x minus mean over standard deviation, we have 110 minus 105 over 20. The answer is 0.25. Since the answer is positive again, therefore 110 is above the mean. So let's try another test. Raul has taken 2 tests in his chemistry class. He scored 72 on the first test, for which the mean of all scores was 65 and the standard deviation was 8. He received a 60 on the second test, for which the mean of all scores was 45 and the standard deviation was 12. In comparison to other students, did Raul do better in the first test or the second test? For a score of 72, so using the same formula, x minus mean over standard deviation, so we have 72 minus 65 as the mean of all score over 8. And the answer is negative 0.88. For a score of 60, using the same formula, x minus mean over standard deviation, so we have 60 minus 45 as the mean of all score over 12. And the answer is 1.25. Now, the question is, did Raul do better in the first test or the second test? The answer is yes. Raul scored better in the second test than he did on the first. Let's try one more. What if the z-score is given on the problem? A consumer group tested a sample of 100 light bulbs. If found that the mean life expectancy of the light bulbs was 842 hours with a standard deviation of 90, one particular light bulb from the Durabright company had a z-score of 1.2. What was the lifespan on this light bulb? So using the formula, x minus mean over standard deviation, the given is z-score is equals to 1.2 and the mean is 842 and the standard deviation is 90. So we have 1.2 as the z-score, x minus 842 as the mean over 90. In this equation, we're going to find the LCD or simply multiply 90 to 1.2 and the answer is 108 equals to x minus 842. Now, we're going to add 842 to 108 or simply transpose 842 to 108 and the answer is 950. Therefore, the light bulb had a lifespan of 950 hours.
Hi, my name is Errol Oñedo from BSA 1L, and today we're going to discuss about the percentiles. Now, what is percentiles? Percentiles are positional measures used mainly in educational and health-related fields to indicate the position of an individual in a group. For example, the graphs and tables show the percentiles for various measures such as test scores, height, or weight. Percentiles, denoted as P of X, divide a set of data into 100 equal parts. They are used as positional measures to indicate the percent of the data set have a value less than a specified value. Always remember that percentiles are not the same as percentages. For example, if a student gets 72 correct answers out of 100 items on a test, they earn 72%. That's what they call the percentages. Or, in a summary, 72 over 100. But, if a score of 72 correct answers corresponds to the 64th percentile, then they did better than 64% of the students in the class but still received a score of 72%. That's what they call a percentile. How to find or calculate the percentile? The percentile formula determines the performance of a person over others. The percentile formula is used in finding where a student stands in the test compared to the other candidates. A percentile is a number where a certain percentage of score fall below the given numbers. Let's discuss this percentile formula in detail and solve a few examples. What is percentile formula? The percentile formula is used when we need to compare the exact values of numbers over the other numbers from the given data. In short, the accuracy of the number. Often percentile and percentage are taken as one, but both are different concepts. A percentage is where the fraction is considered as one term, while percentile is the value below the percentage found from the given data. As I always mention from the very start, percentage and percentile are different things. In our day-to-day life, percentile formulas are usually helpful in finding the test scores or biometric measurements. The percentile formula is shown like this, where small n is the ordinal rank of the given value. The capital N is the number of values in the dataset, and P is the percentile. The percentile formula can be also shown like this, where percentile is equals to number of values below x over total number of values times 100. Now, using the percentile formula, let's take a look for the following example. The scores obtained by 10 students are 36, 48, 50, 59, 61, 66, 75, 79, 80, and 92. Using the percentile formula, calculate the percentile for score 75. The first thing we need to do is to arrange the number in ascending order, or from lowest to highest. Next, count the number of values below x. The x we're talking about here is the 75. Counting the number of values below x, we have 1, 2, 3, 4, 5, 6. Using the percentile formula, which is percentile equals to number of values below x divided by total number of values times 100. Then, we are going to substitute the value. The number of values below x is equals to 6. The total number of values is equals to 10, since we're talking about the 10 students who scored the following numbers, times to 100. The number of values below x is 6, divided by the total number of values, which is 10, is equals to 0.6. 0.6 times 100 is equals to 60. Therefore, the percentile for score 75 is equals to 60. With this result, the student who scored 75 is higher than the 60% of score of his or her fellow student. Example number 2. The weights of 10 people were recorded in kilogram as 37, 45, 47, 59, 60, 62, 71, 73, 90, and 77. The first thing we need to do is arrange the following dataset in ascending order. Therefore, we can finally have 37, 45, 47, 59, 60, 62, 71, 73, 77, and 90. Now, the problem is, find the percentile for the weight
60 kilogram.
The number of people with weight below
60 kilogram.
is 4. Now, using the percentile formula, we can finally substitute the value. The number of values below x divided by total number of values times 100. With this formula, we can finally find the percentile for the weight
60 kilogram.
The number of values below x is 4. The total number of values is 10. 4 divided by 10 is equals to 0.4. 0.4 times 10 is equals to 40. Therefore, the percentile for weight
60 kilograms.
is equals to 40. With this result, we can finally derive the following conclusion. The person who weighs
60 kilogram.
is heavier than the 40% of the people with recorded kilogram and weights. Thank you so much for your time.
Box and whisker plots. A box and whisker plots, sometimes called a box plot, is often used to provide a visual summary of a set of data. A box and whisker plot shows the median, the first and the third quartiles, and the minimum and maximum values of a data set. Construction of a box and a whisker plot. Number 1. Draw a horizontal scale that extends from the minimum data value to the maximum data value. Number 2. Above the scale, draw a rectangle box with the left side at quartile 1 and its side at quartile 3. Number 3. Draw a vertical line segments across the rectangle at the median quartile 2. Number 4. Draw a horizontal line segment called a whisker that extends from quartile 1 to the minimum and another whisker that extends from quartile 1 to the maximum. Contrast a box and whiskers plot. Historical note: John W. Tukey, 1915 to 2000. Made many important contributions to the field of statistics during the career at Princeton University and Bell Labs. He also invented box plots when he was working on exploratory data analysis. Plot is a method for graphically depicting group of numerical data through their quartiles. Box plots also have their line extending from the boxes, indicating variability outside the upper and lower quartiles. As a box and whisker plot for the following data: 86, 77, 58, 45, 94, 96, 83, 76, 75, 65, 68, 72, 78, 85, 87, 92, 55, and 61. Arrange from least to greatest: 45, 55, 61, 65, 68, 72, 75, 77, 78, 85, 86, 87, 92, 94, and 96. The first quartile is 61. Second quartile is 75 because it is the middle number. First quartile, 61. Second, 75. The third quartile is 86. Number line. Line. First quartile, 75. The middle of 70 and 80. Second quartile, and the first quartile is 61. Third quartile is 86. List number is 45. Greatest number is 96. Box plots are popular because they are easy to construct and they illustrate several important features of a dataset in a simple diagram. Note from the box plot in example 6 that we can easily estimate the quartiles of the data, the range of the data, the position of the middle half of the data as shown by the length of the box. Make a box and whisker plot for the following data sets: 7, 3, 14, 9, 7, 8, and 12. Arrange from least to greatest. 3, 7, 7, 8, 9, 12, and 14. Find the middle number. 8 is the middle number, so it is the second quartile. Find the middle number of these three numbers, and the first quartile is 7. The third quartile is 12. Number line. From 1 to 15. First quartile is 7. Second, 8. The third is 12. The least number is 3. And the greatest number is 14. Some graphing calculators can be used to produce box and whiskers plot. For instance, TL83/84, you enter the data on a list. The window mean is used to enter appropriate boundaries that contain all the data. The box and whiskers plot, the key enable to view minimum and maximum.
Hi everyone, my name is May Hipolito Talangan from PSE 1L. Today I am going to discuss about the quartiles. So let us determine what is quartile. A quartile is a statistical term that describes a division of observation into four defined intervals based on the values of the data and how they are compared to the entire set of observation. On the quartile, it is important to understand the median as a measure of central tendency. The median in statistics is the middle value of the set of numbers. It is the point at which exactly half of the data lies below the above and central value. The quartile formula helps to divide a set of observation into four equal parts. The first quartile lies in the middle of the first term and in the median. The median is in the second quartile. The middle value lying between the median and the last term is the third quartile. Mathematically, they are represented as follows. When the set of observations are arranged in ascending order, the quartiles are represented as number 1. Calculate the median, lower quartile, upper quartile, and interquartile range of the following data set of values. The solution is arranging the values in ascending order. So, we arrange the numbers in ascending order. Putting the values in the formulas above, we get median is the quartile 2 and the fifth term is 23. The lower quartile is in the mean of 2 and 3 terms. So, 20 plus 21 divide 2 is equal to 20.5. The upper quartile is the mean of 7 and 8 term. 25 plus 26 divide 2 is equal to 25.5. Example number 2. What will be the upper quartile for the following set of numbers? So the formula for the upper quartile is Q3 is equal to 3/4 close and open parentheses n plus 1 and third. The formula, instead of giving the value for the upper quartile, give us the place. For example, 8th place or 10th place or etc. So firstly, we put your numbers in ascending order. There are a total of 11 numbers. So, quartile 3 is equal to 3/4 close and open parentheses n plus 1 and term. If we convert it, 3/4 the n is 12 and the nth term is equal to 9 terms. Solution, the upper quartile 18 is in the 9th term or on the 9th place from the left. That's all. Thank you.
Now, we will be discussing a way to present a data, and that is using the stem and left diagram. Stem and left diagram is one way to present a data wherein we are doing the breaking down of its digits into place values. So that, after doing this stem and left diagram, we will be giving an overall impression of the data. So to do better understanding, let's suppose we have the data of ages of the tourists going to a certain tourist spot in Barangay San Jose from these days. As you may notice, these data are already arranged from the lowest value, which is 14, and to the highest value, which is 75. So as I've mentioned, we have to be familiar again with the place values of different digits. So say for example, we have this 14. What we're going to do is to break it apart. So the 1 will stand for tens place. And will stand for tens place. And 4 will be the ones place. So it depends upon the data as to what place value will be broken. In this case, since all of our data have the highest place values, which is tens, so we will just use the tens in the ones place value. Okay, so first, let's draw a vertical line. And that vertical line will signify the regions for the tens and for ones. This left part, the part for the tens, that is, we will refer as the stem, and this part will be containing the leaves. So again, let's use 14. We'll break down 14 to 1 and 4. Next, we will have 17. Since 17 share the same tens digit as 14, we'll not write 1 again. We'll just put 7 next to 4. It means the data having tens values of 1 have 2 qualifying data in that condition. So which are 14, 1, 4, and 17, 1, 7. This goes on and on until we have written all the data. Grouping, of course, those data having the same tens digits. Doing that, we will arrive with this stem and left diagram. As I've mentioned a while ago, 14 and 17 will share the first row because they both have the same tens digit, which is 1. Until next is 21 until 28, all of them will be written in the second row because all of them have the same tens digit, which is 2. They will be written like this. That same principle goes for line. Yan. That same principle goes for line 3, 31 until 39. This line. Line 4, 41 until 48. This line. Line of 5 with just 4 elements. 52 to 54. This line. And line of 6, and the line of 7. After finishing the stem and leaf diagram, we can derive of new things regarding in data set. First, most of the tourists that visited the tourist spot in Barangay San Jose are age 40s. It means 41 to 48. The least number of the tourists are those age 70s. Specifically, we only have 1 tourist, followed by the teenagers starting from 14 and 17. So, this is what we mean when we say we are all given the overall impression of the data. We can see when the data lie closely to each other, in which the extreme in this case are 70s and teens. In line with that, we can visualize what this data means. So this data can be a basis for the owners of the stores in that tourist spot so that they can have more improvement on their businesses. So that's it for the stem and left diagram. Remember that this first column, the column on the left of the line, is the stem, and in the right column is called the leaf. I hope you learn more about dataset using the stem and leaf diagram.